Hello student, welcome to our channel The Physics Point. In the previous lectures we just started discussions of some instrument which is used to measure the pressures, and we discussed the one instrument in the previous lecture, that is mercury barometers, and the remaining and second instrument will be discussed in these lectures, the structure, construction and functions of that instrument. The second instrument is the second instrument of which is used to measure the pressure, that is open tube manometers. Open tube, it is manometer. Open tube manometer, the second instrument which is used to measure the pressures, that is open tube manometers. It is a U-shaped tubes. It is a U-shaped tube. U-tube. It is U-shaped tube. It is a U-shaped tubes, and they partially filled by low density liquid. The partially filled by low density liquid. Some examples of that low density liquid is water or kerosene. These are the liquids which have the low density, and this which is help to maintaining the larger level difference between the two arms. Okay, let's draw the diagrammatic representations of the open tube manometers. It consists of U-shaped tube, and they have two arms. And कसे असतात, दोन आर्म असतात, ठीक आहे. And in between these two arms we will fill with the low density liquid, that is maybe water or kerosene, which is help to maintaining the larger difference between these two arms, level of these two arms. The one arm is open in atmosphere. ATM, it means atmosphere. One arm is open in atmosphere. कसा आहे, atmosphere मध्ये open आहे. Then another arm is connected to connected to a container. Connected to a container, that is the container आपण या ठिकाणी नाव दिलेलं आहे, this container D. I have the nomenclature of this container, that is container D. Okay, consider a point, that is एक पॉइंट घेतलेला आहे या ठिकाणी. आपण काय केलं, पहिल्यांदा लिक्विड फिलअप करून घ्यायचं यामध्ये. Low density liquid I will fill in that types. Okay, consider a point R on the surface of liquid with open atmosphere. On the surface of liquid surface of liquid in open atmosphere. The point R is in here. That is point R. Consider a point R which is present on the surface of the liquid, and the surface is open in atmosphere, and the pressure at a point R is equal to pressure, atmospheric pressure, that is PO. Consider a point T which is exposed. एक पॉइंट अजून एक पॉइंट घ्यायचा या ठिकाणी. कन्सिडर ए पॉइंट T which is exposed to pressure of the gas which are present in the D. Another which is present pressure exposed by the gas from D, that is point D. See there, it means consider a point that is T, pressure exposed from gas in container D, and we just measure the gas which are present in the container D. यातमधून असलेला जो प्रेशर गॅस आहे त्या गॅसचा प्रेशर आपण मेजर करायचा आहे. And the another point that is I will be treated, the another point is S here, and the difference between these 2 points, that is H, is the height of that pressure, and another point that is S is open, it's like in the open arms, in the open arm which is same level, and which is in open arm and same horizontal level, same level of T, same level of T. Then the pressure at a point S, from the equation pressure at point S, pressure at S, that is equal to P of S, it is P of 0, P of S is equal to P of 0 plus H is the height of that liquid column, rho is the density, and acceleration due to gravity, that is G. And the treated this equation is equation number 1. काय काय केलं, एक यू शेप ट्यूब घेतला, त्यामध्ये लो डेन्सिटी असलेला वॉटर किंवा कुठल्याही लिक्विड ऍड केलेला आहे, आणि जे पॉइंट्स आहेत, एक आर्म ओपन सोडलेला आहे, एक आर्म इज ओपन टू द एटमॉस्फेयर, and another arm is connected to one of the container. The container is called D, and the pressure which are in the container D will measured in this lectures. Okay, then the pressure at a point R is the atmospheric pressure, that is P of R is equal to P of 0. Then consider another point, that is a T. The pressure at the point T is exposed by the gases or any fluid gases which are present in the containers. Then another point, that is the another point S is open, another point that is S in the open arm, another point S in the open arm, and same level of the T, same level at the T, and the pressure at a point S is equal to P of S is equal to. Then यामध्ये जर सेम असेल तर प्रेशर कसं असणार आहे. ओके, जस्ट then if the pressure at a point S is a P of S and they have present in the same level, that is at point D, the pressure at point S is equal to pressure at point T. This is the equation number 2. According to the Pascal's law, according to the Pascal's law, the pressure at every point in the incompressible liquid in an equilibrium state is the same. Pressure at any point in that point and pressure at this point T, यावर असणारा जे काही प्रेशर आहे, यामध्ये असणारे फ्लुइड्स आणि यावर या कंटेनर कुठल्याही प्लेसेस वर असणारा जो प्रेशर इज सेम असणार. Then the pressure at point T is equal to the pressure in the D, according to Pascal's law. According to Pascal law, pressure at every point of incompressible liquid in equilibrium state is the same, then the pressure at a point T is equal to pressure in a hole, that is P. आपण measure करायचा pressure in the D, then that is P. Just measure the PS is equal to also P of T from the equation 1, 2, 3. That is, this equation is 3. We just measure, that is P. Okay. या दोन्ही इक्वेशन्स जर लेवल्स हॉरिझॉन्टल लेवल सेम असतील तर PT इज इक्वल टू P0 प्लस असं देखील लिहिता येतं. देन या ठिकाणी आहेच PS इज इक्वल टू PT. अँड व्हॉट इज द PS? PS इज इक्वल टू द P इज इक्वल टू, दॅट इज P ऑफ 0 plus H rho into Z. This is the equation number 4. In the open tube manometers, they only measure the gauge pressure. What is the gauge pressure? The pressure difference between the atmospheric pressure and total pressure is called as gauge pressure. The difference of pressure between the between the total pressure of the fluid and atmospheric pressure. म्हणजे P minus P0 is equal to P minus P0 is equal to H rho into Z. This is the gauge pressure. In the open tube manometer, it only measure the gauge pressures. एक छोटा सा ट्यूब घेतला U tube, that is U shaped tube. One arm is open to another arm is connected to the D, and which one will present in the only maybe gas or liquid present in the D container D will be measured in this lectures. प्रेशर म्हणजे D या कंटेनर मध्ये जे काही मटेरियल्स आहे, गॅस आहे, लिक्विड आहे, त्याचा प्रेशर आपण काय करतो? मेजर करतो. अँड दिस प्रेशर इज एक्सपोज्ड ॲट अ पॉइंट T. या पॉइंट T वर जे काय प्रेशर एक्सपोज्ड करतं त्यामुळे काय करत असतं? डिफरन्स प्रोड्यूस होतो. डिफरन्स विल बी प्रोड्यूस्ड ड्यू टू अ प्रेशर or due to a gas which are present in the container D, they produce some pressures or exposed some pressures, and this is main reason we are taken a low density liquid. Okay, low density liquid, water or maybe kerosene. बाय पॉइंट कन्सिडर केलाय, त्यामधून मेजर डिफरन्स एक आहे कन्सिडर करून आपण काय केलं, जे प्रिव्हियस लेक्चर मध्ये केलं तेच याच लेक्चर मध्ये केलेलं आपण, दॅट इज ओपन ट्यूब मॅनोमीटर्स. वी जस्ट फिनिश द टू इंस्ट्रूमेंट विच आर यूज्ड टू मेजर द pressure, and in the next lectures we start to discuss the main different points, that is the surface tension, the tension present or the tangential force applied at some different points, okay, which are discussed in the next lecture.